So good morning, everyone. So what we'll do is start off with a review of what we did last time. And we'll talk about wrapping up assignment number 2. And then do an introduction to joins to get you started for assignment number 3. Assignment number 3 is going to require working with joins. And that content coverage will take a little bit of time. So what I did was this morning, I changed the due dates by 5 days for assignment 3, 4, and 5. So I pushed them out a little bit. That gives us about 13 days, if you will, from assignment 2 for assignment 3 completion. Joins is a very key topic, so that's why the change. Let's focus on the content for assignment 2 and review that a little bit. So we were talking about working with SQL statements last time. So we had the coverage of the where clause, generally speaking. So we had talked about using the where clause with arithmetic. Using arithmetic expressions in the where clause, using operators. We have not talked a lot about the null values, which I'll focus on today. And then there are also group by and order by, and we can do a light introduction to that. As part of your review, I'm going to basically skim through these slides to just refresh your memory on what we had covered. So understanding the where clause in general will basically restrict rows conditionally from the data. And currently for lab 2, you're focusing only on one table at a time. But however, we can write multiple conditions. So this is what a where clause would look like to bring out salaries greater than 3,000. We'd also talked about the notion of a Cartesian product, and I had asked that you guys might consider looking at the link for set theory on Wikipedia so you can get introduced to the idea. That is used a lot when working with data sets in SQL. So we can write more than one condition using different operators, AND operator or the OR operator, right? So we can basically, when we work with an AND operator or the OR operator, the way the conditions get evaluated using true and false mechanism basically puts the results, brings out the results of the query. So if salary greater than 3,000, that condition will be applied to a row. If the salary is greater than 3,000 in that row, then that row is selected. Then we also go in that row and say, is the employee number 7566? And if it is, then if both of those conditions are true, then we end up selecting the row. Otherwise, if one of the conditions is false, then we eliminate it. So condition writing is an art in itself that we have. We can have multiple operators. We can have expressions, arithmetic operators, comparison, character, logical, in and between operators. So we went through patiently each type of the operator. Here we are looking at the where clause in an update statement. So that limits the rows that will get updated. Update statement with, a where clause with a subquery. Arithmetic operators and precedence is somewhat important. The order in which the operators are solved is very, very important. Arithmetic operators can be used in the where clause. So, and the precedence is used to enforce the priority. These are all the different types of operators we did focus on. So you got your comparison operators for single row operations, and then multiple row operators in any and all. In this discussion, I am choosing to ignore the multiple row operators because we're going to spend about an hour on these topic, or at least 45 minutes on this topic separately when we get to closer to lab 5. These are the different comparison operators that are applied. Then there is the is null operator, which is always used to figure out if the value is null. We cannot use the equality operator to signify if the value is null or not. So we must use the is null operator. Null value, generally speaking, is an unavailable, unassigned value. It's usually an unavailable, unassigned value. And usage of in, basically we give a data set and we say if the employee name is in this set, then we will select the row. Be mindful that select statements, where clause is used for selecting specific row. So kind of please be aware of that. If salary is greater than any of these values. So the in operator is an equality. E name is equal to King or E name is equal to Jane, right? But when we say salary greater than any, so we can bring in a relational operator with the with multiple values, or comparing it with multiple values. And this is with salary greater than all. So concatenation operator is generally used with strings and data type. And so concatenating strings can be accomplished by using this double pipe symbol operator. Sorry, I'm not flying through the stuff. It's just that we have covered it before. So, and we've also talked about the usage of the like operator and using wildcards like the % sign and the underscore. And if you are actually looking for an underscore or a % sign in the string, like we are here accounting underscore, then we have to represent the character with a escape character and then define that later. Escape character can be any character on the keyboard. Then we come to the logical operators using and, or not operators. And this is basically conditional logic where you can look at how conditions are in fact evaluated. And this particular slide gives you an idea of how the logical operators are evaluated. When we say true and true, true or false, true or true, what the outcomes are. Generally, with an AND operator, both conditions have to be true for the result to be true. With an OR operator, only one of the conditions has to be true for the result to be true. Then we have a little more analysis with, using more than one condition and using precedent, or using brackets to set precedent. So, then we have in and between operator. In operator is for multiple, like it's a multi-row operator. So if you were trying to compare more than one value. And between is being used for selecting the value between 3 and 4. And this is where we had stopped. We had to talk about null value. Before I continue, I want to make sure that if there are any questions on assignment 2 that need to be addressed, that I can potentially address right now with you guys. So assignment 2 is writing a bunch of these, and a lot of you have they've started coming in already, which is a good thing. So are there any questions that can be addressed on any of the questions in assignment 2? I'll just lay them out here. So while you guys might be thinking of questions, when you are working on question number 4, showing employees where last name has 2 L's. So here, using the trim, for using trim and where clause is very important, because we are dealing with fixed length string. Okay. Using trim and where clause is very important. So, so we might say something like this, where trim name like, and then you know, coming up with wildcards to get 2L, which obviously I'm not going to focus on. You have to use % in there in some combination to make that happen. So this part I'm not focusing on. That's for you to, but you know, you should be able to support names like Sally, Alan, and Laurel. So 2 L's in the name, either together or for her. Any questions on assignment 2? For the question 4A, it is 2 L's in the name or L's in the name. So names like these, right? If to answer your question, right? Does that address it? So you can get, when I say 2 L's, meaning 2 letter L's, either next to each other or for, okay? So, all right. So when you're ready to submit your assignment, you can copy the query and the result and send that to cislabco5@gmail.com. So, okay. Okay, so let's talk about null values. Can you please comment on how to submit the assignment, like exactly what I should do? Okay, sure. Absolutely. How to submit lab assignments. So you can write your queries in a text editor, and when you have the final query, run it in SQL Plus and copy and paste the output in below the query. So I'll probably have like something like this, like rem question 1, and then let's say I have a query, select star from EMP where employee number is greater than 1,000. Let's say that's the query I'm submitting as an answer to the question, right? And then I will take this query and run it, and then I'll have output. So just add a comment and then paste the output here. When you paste the output, you know, keep doing this for each question. And then take this file and save it as lab2.txt, and then email it to cislabs05@gmail.com. Please make sure you also add in the subject line CIS64B as 2 separate words, and then whatever lab number you're submitting, and make sure there is some header information that I request in the syllabus should be added in the body of the email. So because I'm getting a lot of emails, so this header, adding this in the subject line is very important, and adding the information that I asked for in the syllabus for which is basically your name, class, lab number, etc. So please put that. And rem is the comment. So we use rem to write a comment in SQL. So yeah, you are basically submitting a text file as an attachment in an email, and I am requesting that you all provide me with this information, right? So please include this information in either in the text file or in the email that you send. Because a lot of times your email addresses don't have your full name, like legal name, accurately reflected. So that's why putting it in the body of the email helps me understand who is submitting the assignment. Otherwise, I have to make guesses on who is submitting. Okay? So let's continue to the next point, which is working with null values. So null value is a special character that it does not occupy any space. It's not a zero, and it's data type agnostic, meaning null value can be applied to any data type, string, date, number, etc. So, okay. Columns of any data type can contain null values unless they are defined with a not null constraint or primary key constraint. Does everyone understand what a primary key is by now, based on your Lab 1 experience? Very nice. So anything that you add to a null becomes null. Like when we divide by null, the value is null or unknown. But when you divide by 0, it's an error, right? So null, if used in an arithmetic expression, like if I take total salary plus commission, and if I didn't get any commission that year, then basically we get a null in the end. And we have this special operator we have to use to qualify if in fact the value is null or not. Something like that. Cannot do this because it will not result in an error, but it will also not show any rows. So here are the other clauses. Group by, having, an order by. So if you're trying to figure out like what is the total of all salaries in a department, we'll use the group by clause. If we want to say, I want to take total salaries of all employees in all departments that have total salary greater than 5,500. In that case, I'm going to use group by and having together. So you guys will end up learning group by and having. You guys will end up using group by and having down the road when we get closer to lab 5 in more depth. So this is how group by works as a quick example. So we're trying to figure out total salaries of all the departments. So we provide a group function, and then we say we want to group by department number. And then order by is of course for sorting data on multiple columns. So you can control if the data should be sorted in ascending or descending order. And null values are displayed last in ascending. So null value by comparison becomes the largest value, right? Null value becomes the largest value. And this is how it's done. So if you want to say ascending or descending, you know, we can just simply change that to ascending. So the next, sure, yeah, absolutely. There's the group by clause. So the group by clause is here. Did you have a question about? Okay. So we can say sum of the, like we can provide a group function and then a group by, the group by column that we, or column name that we're going to do a group by on. And there are certain rules of usage of group by that will be covered like down the road. First chapter or the first lecture on syntax covers the entire word clause. So now we get to the next part, which is actually more exciting because what we want to do is start working with more than one table, which is illustration of working with joins basically. So let me working with more than one table. That's the goal of this chapter. When you can understand what is a join, different types of joins, and the new join syntax, that is, like there are two ways to create joins. There's the old and the new one. We'll learn both, and then the join view, which is another concept to apply with primary key, foreign key relationships in two tables. So join is something when you take data from two tables. And it says that row in one table is joined using primary and foreign key. And join is always written in the where clause. So it's nice to see this slide, but I think let's look at some data sets so we can make meaning of join. Can everyone see this? Excel sheet, I'm going to display a few things for you guys here. So we're going to have the employee table and the department table. And in the employee table, I'm going to have employee number, name, salary, and just department number. And in department table, I have department number, department name, and location. So by reference, employee number is the primary key here, which means that all the employee numbers should be unique values. So, and department number is also going to be the primary key. And so department numbers will be unique as well. We just have 2 departments and 4 employees. So department name can be accounting and engineering, both in Santa Clara. And then in the employee table, I have Bob, Harry, Sally, and running out of names today. I guess I'll use some of your names. Mustafa. Sorry, not enough coffee today, guys. So I get a salary of, say, I don't know, $10,000. Harry makes 12. Sally makes 15. And of course, Mustafa makes the most. And then department number, I can't be in accounting. I am really bad at it. So, so there we go. Sally's our accountant. So now we want to produce a report where we want to take department number, that's the foreign key, right? So this refers to this by color, and these 3 refer to, sorry, I'm using some arbitrary colors, right? Anyway, so we want a report that can show that Mustafa, Bob, and Harry work in engineering using a query, right? So we want to be able to show a report like this, where we say we've got name, department number, and department name. So it can have Bob, Harry, and Mustafa with our respective department numbers and the name. So you see, this foreign key is kind of acting like a lookup, like we have a key too, and we can do a quick lookup in this table and say 2 is engineering, right? Now, to get to this result, we have to go through a process. So the process is to do a Cartesian product. So I'm going to say select name, department number, and dname from EMP, department, semicolon. So when I write this query, by the way, I will be posting, I should save this Excel sheet, and I'll post this in the notes for you all. So that way you guys can have it, right? So if I say this query, select, the first thing I want to get is an ambiguity error, right? Because we don't know which department number we mean. Do we mean the one in employee table, or do we mean the one in department table, right? So I'm going to have to qualify that. So we will say the qualification is by creating the aliases, and because I only have one name, right, it doesn't matter because column names are unique. So I can qualify that, I want department number from the employee table, from the department table. But if I want to bring in the employee table from the employee table as well, I can select that. Which I think is a good idea because we'll learn something. So we're going to look at name, E dot department number, D dot department number, and D dot P. So when I first run this query, and just so I can show the query properly, if I run this particular query, this is going to create a Cartesian product. So I'm going in, and when I'm making a Cartesian product, I'm going to have name as what? Bob, Harry, Sally, and Mustafa. And in the employee table, we basically see it as 2212. That's what we select. And in the department number across, when we do the Cartesian product, we basically say D dot department number 1, 1, 1, and 1. So we bring in this multiple times. This is how we multiply the data set. D dot, no, it's actually D name, sorry. Right, I'm not using a alias with that for now. So, yeah, it's just D name. Thank you for that. So then I'm going to repeat this process, and we're going to bring in department number 2, and we'll say engineering. Okay. So this is what happens when we create, this is the Cartesian product. This is what happens when we select the data with a query like you see on the left side. Sorry about that. When you see this kind of a query, right? Shows this. So now if I go in and I say, I want to basically select the rows where there is matching values. So those highlighted rows are matching values. And then, so to do something like that, I would need to say, where E dot department number is equal to D dot department number. So I'm taking the foreign key value, right? I'm taking this value and matching it with the department with the primary key. Why is D dot department number not equal to E dot department number? It can be either way. Are you asking why are like these rows, Mustafa, is your question that why are these two rows not matching that I'm selecting right now? Oh, that is the function of the Cartesian product, right? When you multiply sets, you take the value of you take the value from, we take the row from the first set and represent it with every row of the other. So I'll take these 4 rows and represent it with the first one. Then I'll take these 4 and represent it with the second one. And that's the definition of the Cartesian product. That is set multiplication. No, it does not. The system, when you do a Cartesian product, that does not match. It's the join condition later that matches it. And that's what we are trying to understand, right? So it's when you write that condition, that's when these colored rows will be selected, and that'll give us the end result that we choose. Actually, not yet, because we only are interested in engineering, right? So when we do this, part, that brings out all the rows that match. So the result of the query will be something like this. So I'm going to take all this data, so I need to make room for this, so bear with me, guys. So I'm going to delete all these rows. And the ones we are going to keep are the ones where values are matching, basically. And the rest of the data set is gone. So my point is, this is after the join condition. So if we say where, then we get this part. So now the next thing is to say that we are not interested, at least in this query, we are only interested in folks that in printing data for users that are, or for folks that are that are in engineering. So then I can modify my query and say where E dot department number equals D dot department number and D dot name, or D name, excuse me, I don't know why I keep saying that. D name is equal to engineer. So when I apply this AND condition, then only these three rows are selected, producing the final desired result. So when I take a combination of this is what I get. So to parse this entire query with a data set helps me understand very clearly how joins work. And that's what I'm trying to do here with you all, so you get it. Does this story make sense to everybody from top to bottom? It is like a matching system. Can you think of primary key as composing several fields together? Yes, absolutely. See, the point of the primary key when I refer to employee number 1 or employee number 3, the point is basically that as long as I refer to number 3, I can get this entire value. So all these columns are essentially dependent on the primary key. And when you think of the Cartesian product in using the primary key and foreign key, here I'm basically saying, department number 2 is referring to this row. And here department number 1 is referring to this row. But when we do the Cartesian product, we do have to do this multiplicity and then apply the join condition to select the matching values and then eliminate further as we need to. Yeah, technically, yeah, again, you're right. So the thing is, in the final query, I will not show. So the question is like, you should have both columns because that's how the query is, right? And I brought both of these just really to show you guys how the joins work. So, because this is at the heart of how join works. So, okay. Any questions on joins as we get started here? So what we are doing is, join is a concept, but in certain syntax it also becomes a keyword. But right now, the way we are writing, we are using the old syntax. And so when we use an equality operator like this, that's a join concept. Okay. Okay, so I'll be sure to put this I'll be sure to put this spreadsheet online for you guys so you can refer to it. Okay. So let's move on. So this is what we are saying. Joins are used to query from multiple tables. Rows in one table are joined with another using primary and foreign keys, as I just showed you. And join condition is always written in the where clause. So these slides are actually pretty good notes, but visualization is also important, which is what I was trying to do earlier. So what we do in the from clause is we add two or more tables separated by comma. And this is kind of what we're talking about, right? And then the select column, the select list can include any of these, right? And the where clause is where the join condition goes. So when you have two tables, you need one join condition. If you have three tables, you need two join conditions, and so on. Okay? The where clause is going to have the join condition. And when you are using columns involving multiple tables, creating an alias is very, very helpful. And you can have columns with same names in two different tables that can be referred to using the clause. I mean, using the alias, excuse me. That is just to avoid ambiguity. Cartesian product is the result of joining two tables. And what happens in the Cartesian product is we select values from each table for determining the final result. You can only imagine when we end up figuring out Cartesian product, the number of rows that are considered in the query is significantly large. So we have to therefore then tone down the data set with the where clause. I mean, just think of performance consequences. And then we add the where clause between primary and foreign key. And finally, what happens is the condition gets applied to reduce the number of selected rows. So these are few things regarding that you have to keep in mind when you're working with the join condition. We have total number of join conditions should be equal to number of tables minus 1. When we are writing the joins, they should be compatible data types. And column in one join condition need not be in the select list. Generally involves an equality operator, but other operators can be used. And we can have additional search conditions like we applied in this query. So one thing I want you to please consider is the ramifications or the significance of using a non-equality operator in a join condition. And see if that makes any sense. So I'll pose this as a question to think about. Does it make any sense at all for using a non-equality operator in a join condition? right? So think about that, please. So that's where we get equijoin or a non-equijoin. These are terms that we are getting used to. So if you have an equality operator involved, that's an equijoin. If an equality operator is not involved, then we get a non-equijoin. Okay? So non-equijoin would mean using something like the between operator. So these are just different join types that are getting introduced to you today. So, okay? So here is inner, outer, and self join. The equi and non-equi has to do with the operators that are used. So equi and non-equi are operators that end up in the queries. But these inner, outer, and self have to do with how we manipulate the data set. So the one join type that we have looked at is called an inner join. This is also called the regular join, where we have a condition where rows are returned containing data from both tables. So if my join condition is this guy right here, as you can see here, right? If I have a join condition here and I have data selected from both tables where that join condition is satisfied, so basically the colored row. That's an inner join. So inner join refers to data each inner join refers to returning data where condition satisfies values from both tables. So concept of inner join would be something like this, where we select data from both tables, have and start eliminating rows using the join condition and additional condition. Outer join is an extension of an inner join. Here, not only we return the rows which satisfy the join condition, but also rows from other table where the corresponding row values might be null. Please read this sentence and try to understand and digest it. We return the rows which satisfy the join condition and also rows from one table for which no corresponding rows exist in the other table. So what does that signify? What does that actually mean? Well, let's look at the data set. Let's say for Harry, the department number is null. Why would that be the case? Because Harry is a new employee, right? So when I change this, data set completely like this, then when we plug in the ID for Harry in our report, we are going to have two null values in the Cartesian product. Now in the join condition, this value will not be, this row should not be selected. This row should not be selected. Why? Because it does not satisfy this join condition. So if we want to include this row and we want to say that select all the null values, then I have to put a plus sign here. So this is a outer join. You guys see how that works? If I want to select rows that have null values, and I'll put the plus sign on the side where there is a null value. So I have a null value on this side, so if I want to include that, I'll put that. So that would be because it's so this is the starting point of the outer join. And so then the final result will include like this query. So we will need to add the plus sign here too, right? But will Harry's data be selected at this point? Because the row does not match, right? Like because the matching element is not there, so this will be there in the Cartesian product. So will this show up in engineering or not? Because basically, you know, Harry will show up, but we'll have all these values as null. So all these values will basically show null in the result. So we'll see Harry in the output report, but we will see all the engineering, all the members in the engineering group, and since Harry does not have a department number yet, a row will show with his name, but not the department number and department. Concept of outer join. Does this work for everyone? Questions on what is an outer join? If the condition is dname equals accounting, so let's consider that. The answer is yes. So if the condition is like this and dname is equal to accounting, then in that case, I'm going to get this one row, and Mustafa will not show up in the report, but Harry will with null values. Okay? Please go ahead and ask any questions you guys may have, no problem. So outer join. Outer joins as a starting point, or working with joins as a starting point. What purpose does the plus sign serve? It brings out all the matching rows and also all the rows that mean that all the rows that have null value. The point is that I'm trying to find people, I'm trying to find all employees, like when I'm doing joins, I'm trying to find out their department names, plus any employees that may not have a department assigned to them. Similarly, if there's a department that does not have any employees, you would want to know that, right? So purpose of an outer join is to find employees not assigned to a department, or to find departments that don't have employees. So we use the plus operator, and we can have the value, the plus sign aside on the right side or left side, but not both. And generally the idea is that we put the plus sign on the side that is deficient in information. The operator is generally placed on the side of the join that is deficient in information or has a null value. Like here, I put it on the left side because E dot department number. So this could become a left outer join. But if I change my query and I say D dot department number equals E dot department number, then it becomes the right outer join. So here you see the syntax I just went through. There are several restrictions on outer join. Outer join operator can only appear on one side of the expression in the join clause. So you cannot put plus sign on both sides. Not allowed. You cannot put the plus sign on both sides. You cannot have a join condition set up on the same table twice. like the employee table. There's no column called grade, by the way, but this is just showing an example that if a join involves more than 2 tables, then you cannot join. You cannot do an outer join on one table twice in the same query. You cannot use the plus operator twice in the join conditions within the where clause. So outer join conditions contain the plus operator, or when you have a condition, you cannot use an in operator either. You can put plus sign on the right hand side, and that makes it a right outer join. You guys should try that as you practice with, begin to practice with join. Outer join cannot be combined with an OR operator. It can only be used with an AND operator. All these restrictions that exist, I encourage you to please try to write out some queries and see and practice a little bit. So. A condition involving the plus operator cannot use a subquery. So what I do tend to do when I'm writing my midterms or final, I will take these restrictions and phrase questions and ask you to tell me what the output of the query might be. So, excuse me. If a query has a restriction of some sort, I would urge you guys to please I would urge you guys to then know those restrictions and basically say it's a syntax error or it cannot be done, so no rows will show. That makes processing the answers much faster. So please keep that in mind. So if we don't allow usage of a subquery if we don't allow the usage of a subquery with an outer join, what we do is we create a virtual table. So we'll put a subquery in the from clause and refer to that as a table. And then do the join, right? And then we have the full outer join. I mean, if you want both of these conditions satisfied, we want to find all employees and all departments. So some employees may be assigned to a department, some may not be, and vice versa. Some departments may have employees, but some may not. But if we want to see a full report, then we do what is called a full outer join. So we are basically including rows from table A and B, And what we do is we do an inner join, and then we also do two outer joins. So the way a full outer join works, in a nutshell, is writing a query with a right outer join and writing a query with a left outer join. Exact same query. Okay? Exact same query. Writing a query with right outer join and left outer join. And then doing a union. See, when we are using the AND operator, we are using intersection. So like this, we are using a union, and that gives us the result of, parts of the table where corresponding information is missing. Okay? Any questions on getting started with joins? So today we have talked about inner joins and outer joins. And what you can do is for lab 3, start working on questions that require usage of those two join types. Like first one uses an inner join. And actually, first one uses a self-equijoin, so you can't attempt number 1. So I think 2 through 5, you guys can start the work on. So, sure, I can answer your question on lab 2. I think I'm done for today. So what I'm going to do next time, folks, is look at I'm going to look at equijoin. I'm sorry, self-equijoin, and also the new syntax. So these two topics I'll be covering, and then you guys will be ready for lab 3 completely. That is, I think, only in MySQL. The show tables command works only in MySQL. So here you, if you want to see all the tables you have, you query a data dictionary, and I can give you that query. You basically query describe user tables. This is the name of the data dictionary. And you can query this to find, which is the same as show table. And for question number 6, okay, let's open that. Display employee number, name, department number, job for an employee who is not a manager and is not a clerk in department 10. Yeah, that is subject to your interpretation, huh? So what I would do is employee who's not a manager, right? Work with that as a condition, and then combine these two together to answer that question. All right? So that's one way of looking at it. And just write me a comment of your interpretation, so when I'm looking at the query, right, I grade it adequately. MySQL and Oracle are two databases by the same company. MySQL is a smaller footprint, Oracle can basically have larger databases in. Okay. Any other questions for today, folks? Yes, two different databases, and MySQL was bought by Oracle later in the game, so the idea of relational database is the same, but the syntax is a little different. But SQL is the same. All right, guys, this is all for today, and I'll see you guys next week. Have a wonderful week ahead. And if you have any questions, of course, please reach out by email or piazza.